เมื่อโลกก้าวเข้าสู่ยุค AI อย่างแท้จริงคุณคิดว่ามนุษย์และหุ่นยนต์จะเชื่อมถึงกันได้หรือไม่
So now we need more intelligence. We need to sense, to feel, to see. So our work evolved into building autonomous skills for the robot, but also connecting the robot to the human. So the interface that connects the human to the machine is called a haptic interface. The cost for healthcare deployment is going to be much lesser than any cost you can imagine for human life. Doctor from any hospitals within 10,000 kilometers can intervene to check and operate. So this is a new technology that is going to add a lot to human health and save many lives. And now the human can interact with the robot like if the robot was your avatar. So I don't really think the cost is going to be a factor in the deployment. I think it is now the question how fast we can bring this technology to be shared among people in developing countries.
ในปลายทศวรรษปี 1980 หุ่นยนต์ได้เข้ามาเปลี่ยนแปลงโลกอุตสาหกรรมครับ อุปกรณ์ที่ทำงานซ้ำๆอย่างไม่รู้จักเหน็ดเหนื่อยตามโปรแกรมที่ตั้งเอาไว้ แต่โลกของเราวันนี้เปลี่ยนไปแล้วครับ เราต้องการหุ่นยนต์ที่รับรู้ ปรับตัว และเชื่อมโยง หุ่นยนต์ที่ไม่ใช่แค่ทำงานแทนเราครับ แต่ทำงานร่วมกับเรา ยุคใหม่ของหุ่นยนต์อวตารได้เริ่มต้นขึ้นแล้วครับ เทคโนโลยีที่เปิดโอกาสให้มนุษย์มองเห็น สิ่งที่มันเห็น สัมผัสในสิ่งที่มันสัมผัส และนำทักษะของเราไปยังพื้นที่ที่เราไม่อาจจะเข้าถึงได้อย่างปลอดภัยตั้งแต่การปฏิบัติภารกิจใต้น้ำผ่าตัดที่ซับซ้อนไปจนถึงการทำงานในอวกาศครับและผู้ที่อยู่เบื้องหลังนวัตกรรมระดับโลกเหล่านี้ศาสตราจารย์อุสมาคาทิฟแห่งภาควิชาวิทยาการคอมพิวเตอร์มหาวิทยาลัยสแตนฟอร์ดและผู้อำนวยการ Stanford Robotics Lab ห้องปฏิบัติการที่เป็นหัวใจของการวิจัยและพัฒนาหุ่นยนต์ขั้นสูงวันนี้เราจะไปพูดคุยกับเขากันครับถึงอนาคตของหุ่นยนต์อวตารและบทบาทใหม่ของมันต่อโลกใบนี้ครับ
The late 80s, robotics became a very important part of manufacturing. Manufacturing robots are designed to typically work alone. That is, we pre-program these robots, we put them in a manufacturing system, and these robots succeeded to build cars, to process products, to do many things. Well, it's not as easy because in manufacturing, we structure the environment. We precisely put the objects in their locations. In the real world, so now robots has to come to objects and interactions that are not well defined. We don't know where things are. We don't have the structure. So now we need more intelligence. We need to sense, to feel, to see. However, if we start to look at a human do this very easily. So inspired by human, we developed a lot of skills for those robots. Those skills needs to be put together in a plan to execute some tasks, and that means we need still the human to order those skills and put them in a sequence of action to perform those complex tasks. And that means there might be a human helping the robot to perform this. Actually, eventually the robot can perform this task autonomously. Humans have intuition the robot do not have. At the same time, we needed sensors. The technology of material, of building tactile sensors, force sensors also developed. All these technologies are helping robotics to be advanced by using those technologies. So our work evolved into building autonomous skills for the robot, but also connecting the robot to the human. We created interface that allow us to see what the robot is seeing, to feel what the robot is touching, and now the human can interact with the robot like if the robot was your avatar. So the avatar is an evolution of a robot that was working alone for a very specific task, and now the avatar is capable of doing many things in many different domains. Today, we have an incredible amount of technologies that are helping robotics, especially with communication. For avatar, the communications is very important to connect the human to feel what the robot is touching. and see what the robot is seeing and to perceive the information the robot is interacting with through those interfaces. A robotic avatar is going to be your avatar in the water where human cannot reach. The robotic avatar is going to replace a worker at the electrical grid where you have high tension so that the worker doesn't need to be up there in the danger. The worker can operate the robot from far away, underwater, space, different areas. Well, in all these situations, the human can operate as if the human was there, but without the danger. So we separate the human physically, but we reconnect the human skills, experience to those tasks that are very difficult, even for the robot.
So how does this feel and what is the technology behind?
So the interface that connects the human to the machine is called a haptic interface. Haptic interface is sort of a robot that instead of acting on the environment, it is acting on your hands. It takes sensors from the robot and reproduce the same effect on your hand. So if the robot is touching something, you feel like you are touching that thing. So this is very important if we think about medical application. For instance, we are using this technology if you are doing ultrasound imaging on a pregnant woman, you go to touch. The robot is going to touch and feel, and the pressure is reproduced at the haptic side, so you can feel exactly that amount of pressure that you are putting. This is very important for the scan. So radiologists can scan through the haptic device with a robot. However, the robot and the haptic device do not need to be together. So the doctor, the radiologist could be miles, kilometers away from the patient. And in a way, we are going to be able to reach areas in the world where there is no hospitals, because now we can have those robots deployed in mobile clinics operated by technicians where people can be scanned very easily, and when there is a problem, doctor from any hospitals within 10,000 kilometers can intervene to check and operate. So this is a new technology that's going to add a lot to human health and save many lives. This is a future where human will be safe to work in many different applications to assist others. This is a new technology that is coming, and it's very exciting. Yeah, well, I mean, as all technologies, when you do the research and development, the cost of prototypes is high. But as we go to mass production, this cost reduces very much. And in professional application, like for doctors, the cost is very small compared to the medical cost. The cost for healthcare deployment is going to be much lesser than any cost you can imagine for human life. So I don't really think the cost is going to be a factor in the deployment. I think it is now the question how fast we can bring this technology to be shared among people in developing countries for healthcare, in developing countries for minerals and for mining, for construction, to facilitate and save effort and save lives, and also for the developing world where a lot of technologies requires more advanced automation, and this is a way to do this in a safe and in an efficient way.
So as you say, it's gonna be like when it's broadly used, is this gonna be cheaper?
Much more cheaper. Yeah. Well, I mean, as I said, if we look at this technology today, this is a technology in the laboratories. But this technology is coming from many new technologies that are there existing today, and all these technologies are helping advancing the avatar concept. I really think the avatar concept will be accelerated as we start deployment in different areas. I would think medical robotics will be one of the first, and I think this is going to happen very quickly. The robot is going to have more abilities but still the human needs to bring the cognitive abilities to help the robot perform tasks. As much we need robots also needs us. So the future is not one where human will be replaced by robot. Human will be interacting with robot, but in a better working condition. This is a bright side about those technologies that are coming for the unstructured real world. And this is happening very quickly because most of those technologies are here. It is how we are going to put them together, how we are going to deploy them, and we are hearing a lot about different development taking place all across the world in robotic applications. And I really think you are going to see this in not a long future. The robotics is very challenging because robotics is multidisciplinary and it requires understanding of many different aspects. Machine learning technology is going to be a huge part of many aspects of robotics in understanding the world we are looking at, but also we need mechanical aspect to design, we need material to build sensors, we need control architectures, we need interfaces, we need psychology. We use this to help kids. We use this in social context. We use this with art. We use so many different things. And I really think all of that is possible if we can bring people to work together and cooperate in taking this technology forward. Yeah. I mean, we should be. I mean, there is a lot of things today. I mean, a lot of satellites, a lot of junk in space, and to clean it, we need robots. To rescue, we need robots in space. To operate outside of the station, go to other planet and operate. I mean, if you are sending human to space, it's very costly. But if you're sending robots, basically, it is much easier. We have operation on the space station to connect to the planet, to Earth. To operate things. So I think space is a clear application for robotics.
จากการคุยกันกับศาสตราจารย์อุซามาคาทีฟจากมหาวิทยาลัยสแตนฟอร์ดมานะครับทำให้มีมุมมองใหม่ต่อเส้นทางของเทคโนโลยีหุ่นยนต์ในวันนี้ครับว่าไม่ได้มีจุดมุ่งหมายจะแทนที่มนุษย์แต่อย่างใดแต่เพื่อสร้างเพื่อนร่วมงานอัจฉริยะที่ช่วยเสริมศักยภาพของเราไม่ว่าจะเป็นทางด้านการแพทย์ที่ช่วยชีวิตคนในพื้นที่ที่ห่างไกลการทำงานในสภาพแวดล้อมที่เสี่ยงอันตรายหรือภารกิจสำคัญในอวกาศหุ่นยนต์อวตารกำลังปั้นอนาคตที่มนุษย์และเครื่องจักรนะครับจะทำงานร่วมกันอย่างสมบูรณ์มากขึ้นนะครับยังไงก็หากสนใจเรื่องราวดีๆเหล่านี้นะครับกด subscribe หรือว่ากดไลค์กดแชร์คลิปนี้เอาไว้ได้นะครับ